All right, it's the top of the hour, so I think we can get started. Hello, everyone, and excuse me. Welcome to the Mimi interim for today. As usual, please make yourself aware of the IETF note well, in particular the policies on intellectual property and the code of conduct. I'm going to go ahead and take notes today, and for the sake of expediency. And then as for the agenda, we actually have nothing formally on the agenda today. So the floor is open if anybody would like to talk about anything, really. And if we run out of things to discuss, hey, Ron, then we can, I suspect we'll end up wrapping up early.
So I wanted to continue the metadata privacy discussion to the extent possible. I already had a short call with Conrad and Raphael this morning, but so there is a PR here, which there's a PR which we could discuss regarding that. People just bear with me for a moment. And then, yeah, if anybody else wants to, I'll be quiet here for a minute in case anybody else has other things they want to talk about.
Oh, looks like it's all you, Rowan. Is the PR this one that I just put in the chat, number 80? Alternate way to have a semi-private handshake.
Give me a sec, please.
Sure.
Yeah, I just pushed a commit here. So yeah, we can have a look at this.
So do you want to share your screen so you can drive that discussion?
Sure. Let's see. What do we get this? Okay, so, all right. So let's, basically the idea here is that, I'm gonna go ahead and open a rich diff. So the idea here is that we want to avoid having to send public message, because that could reveal information about the membership, even if the members are all pseudonyms, to providers other than the hub. So if we want the hub to be able to see the membership, but we don't want the non-hub providers to see the membership, then an option here is to send an encrypted copy of the message to the hub, or to just send an encrypted copy of the keys for just that individual message. So here, what we have is just the MLS generation, individual message key and nonce, which are used in private message to encrypt a message. And so then this is encrypted using the HPKE seal algorithm with the hub's public key, and we probably need to put a different label in here, but for now I just left that. Encrypting this key and nonce. And then in the case where, if we kind of scroll down here, so if the message that we're sending is a public message, then we just send the public message. If the message is a private message, then we also include this thing this encrypted copy of the key and the nonce. And then the struct looks basically the same as it was before, except that every place that there is a proposal, the two places where there's a proposal or commit, here and here, it's just replaced with this struct. So if it's a private message, we also share the encrypted copy of the key and the nonce.
Raphael's in the queue. Do you want to take that now, or do you want to wait until some other point?
Yeah, go for it.
Go ahead, Raphael.
Yeah. So two things. One, more fundamentally, maybe I missed that, but do we have consensus on the threat model here, that is something we want to design for? Meaning it's fine that the hub sees membership, but we want to avoid that the followers see that. That's question number one. And question number two is, if that's a threat model, why don't we just solve that with oblivious HTTP instead of manually camming stuff to the hub?
Sorry, why don't we solve that with what instead of
oblivious HTTP?
Because it's not clear that the providers are willing to accept an oblivious HTTP message that comes from a local provider, because they don't have any authentication relationship with the sender, unless the hub is the local provider for the sender. So
you mean during fan out?
No, I mean, let's say we have Alice, Bob, and Kathy, each on a different provider, A, B, and C. Bob has created the group, so the group is the hub is B, provider B. Alice sends a message, sends a commit. So if Alice sends the message, presumably she's going to, first of all, this is Mimi is a provider to provider protocol, right? So presumably Alice is going to send this with her proprietary client server protocol. And then the message needs to get sent over the Mimi interface between the local provider and the hub provider, right? So Alice just sending an oblivious HTTP message directly to the hub. The hub doesn't have any way to authenticate Alice. The hub doesn't, we're not defining a client to server protocol in our charter anyway.
But that's not how OHTTP works, right? I mean, Alice would send that to her local backend and then
to her local OHTTP relay.
Yeah. But I mean, it might very well be the case that is too complicated in conjunction with the rest of the server-to-server protocol. So maybe that doesn't work very well. So yeah, but going back to the first question, are we sure we want to design for this particular threat model? Are we convinced by that? I don't feel like we had a lot of discussion on that.
So there was a sort of, not exactly vigorous, but there was substantial mailing list comment on this question about Richard. Let me see if I can dig up the message that Richard Barnes sent, where he categorized sort of four different levels of privacy, of metadata privacy. Tim, do you remember the message that I'm talking about?
No, not off the top of my head.
I mean, I do remember that one, because that was essentially an overview of what we could do theoretically. But then I feel we never, like, there was some consensus that folks were interested essentially in the threat model that now, Brendan's proposal and our proposal is trying to address, and also some interest in, not protecting metadata at all. But I didn't feel like there was a lot of positive response or specific response for this sort of intermediary thing where we hide metadata from the followers, but not the hub.
So let's see, we had I'm looking for the
So I think I found, maybe this is the message from Richard on May 21st, where he enumerates, quote, 3 tiers of privacy we might aim at here. Does that sound right, Ron?
So he's got A, B, C, and D. Hub and followers can see group info and membership. Hub can see group info and membership. Followers see local membership. Hub can see group info and pseudonyms membership. I'll just post this. You said May 31st? I think I'm looking at I've got a May 23rd date, Thursday, May 23rd. And that would have been, couldn't hurt for us to. So there was support from a handful of people for C. So basically the current draft with pseudonymous membership would only be able to provide B, and Me would provide. Yeah, do you want to comment, Raphael or Conrad, on like what level Me would provide?
I think Me falls at least into C, the sense that the hub sees pseudonymous membership.
Yep.
But it does not necessarily mean that followers have to see local membership. So I think Me is somewhere in between C and D. I don't know, Conrad, if you have a different opinion here. So this list does not exactly capture Me. But yeah, I mean, what's different with Brendan's proposal is the pseudonymous part on the hub. That's the big differentiator.
Yeah, Brendan's proposal is D, but it's unclear that
Yeah.
it provides all of the requirements that people have proposed.
If I can jump in here, I think in the MIMIMI proposal we haven't really talked about how the messages, like if there's any encryption between the client and the hub. So I think that's what you want to add, right, Rohan? You want to make sure that the local providers can't necessarily see the plaintext handshake messages.
So I would say I'm not concerned about Alice's local provider seeing something. What I'm concerned about is like the follower for Kathy. So Alice sends the commit to, through Alice's provider A to the hub B, and then when the hub B fans out to to A, B, and C, Kathy's provider C doesn't get to see that Alice and Bob are in the group. That's I think the essence of metadata privacy level C here. And so the encryption that goes to the hub, this happens to mean that the local provider doesn't see what's going on, but it doesn't have to be, for me, that's not the requirement. The requirement is about the followers. So mine just happens, the proposal that is in this PR just happens to accomplish that in a way that hides it for the local provider. But,
So essentially, it's like a tunnel from Alice through her own backend all the way to Bob's hub in that example. Is that correct?
yeah.
But earlier you said you don't mind that Alice's server can inspect messages. So
Yeah. So the fact that that Alice's provider A doesn't see the message, this is just a side effect of the proposal that I made. It's not a requirement for me.
okay. But how is it a side effect? Isn't it the main effect of your proposal?
Well, maybe it's an effect that was not is neither neither a desirable or undesirable effect on it for A from my perspective.
But what is the main intended effect then? Then I don't understand that part. I thought that was the main thing.
The intended effect is that Kathy's provider C, when the message is fanned out, doesn't get to see the membership, doesn't get to see. Well, okay, I guess that there is also, if A gets to see the commits from Alice, then A can glean Kathy's membership, and so she gets to see things that are also outside of A's provider. So I suppose that that is actually important now that I think about it.
Okay, and I need to look at the PR again because I understood it that it would only encrypt stuff between Alice's client and then
the hub.
I mean, from there to the hub, de facto excluding Alice's provider, but then the hub would decrypt it. So I'm not sure I understand how Kathy's provider would only get to see the ciphertext.
Sorry, could you say that again?
So the way I understand the PR is that essentially like Alice's client chems stuff to the hub. And that ciphertext is being relayed via her own provider. But then the hub decrypts that chem. Because it wants to do stuff with it, obviously. And then it fans out the plaintext. And then,
No. It doesn't fan out the plain text. It fans out the private message only.
So, okay. I mean, Conrad has had his hand raised for a while. I need to look at the PR again in the meantime. I don't understand it.
Go ahead.
Okay, so if I understand this correctly, I think this is a great addition to the Mimimi. Like it complements Mimimi quite nicely. And yeah, I mean, it's simple enough. The only thing is that, I mean, I think we discussed this in the call today. The implementations would have to, you know, spit out the key and nonce from wherever they're generated. So that's kind of deep in the engine room of MLS essentially, and kind of pass it out, which is a bit unfortunate, but I think otherwise it's quite elegant. Yeah, I'll take a look at it again, but I think conceptually this is a good metadata privacy addition.
Okay. I see Britta here. So go ahead, Raphael.
Yeah, I just want to interject quickly. So the idea is to cam the key used to encrypt the private message to the hub. Is that correct? That otherwise is only known to members.
Yes. So encrypt the key and nonce that is from the private handshake message.
Okay. Sorry, I completely missed that part.
That encrypted
yeah.
message to the hub.
Yeah, that is indeed what we did discuss earlier. So I fully agree with Conrad. Like in principle, this could work. In practice, we violate a lot of the nice layering we have. So, but yeah, you can think about that.
And the alternative that I was looking at involved sending a copy of the framed message of the commit message. And you know, this also has layering problems because you need to get a copy of the framed message that you were gonna encrypt before you encrypt it. And then you can send a copy of it, and then but you also need to, the hub needs to know that it's the same, that it corresponds to the same content. And so then you need like a hash of that in the AAD, and it's much more complicated.
Yeah, sure. I mean, and that's probably what motivated the member proof document, I guess.
Exactly. Yeah.
But so, I mean, yeah, this sounds relatively straightforward. I guess we need to think about it a bit more, see if there are any downside. But one thing that this still doesn't do, it still does not encrypt the header of a private message, meaning the group ID still leaks. So this, we might have to address that, you know, as well. But of course, I mean, it's better to have more ciphertext and less plain text as a starting point. So maybe this is a good thing to do then. Okay, I'll be quiet now.
Okay. Britta, I'm not sure when you joined, if you had a chance to follow this, but if you have any comments you'd like to make on the, you know, or any concerns about the layering violation, be happy to hear from you.
Thanks. Unfortunately, I did join quite late, so I'm trying to catch up here on the core of what the discussion is. And I don't want to ask everyone to rehash that for my sake, so I can absolutely catch up offline and give further feedback to the list.
Okay. So I'm just going to mention one more concern, which is that if we're encrypting just the key and the nonce, whether a sophisticated attacker could generate a false encryption key and nonce that would make the private message appear to have completely different contents.
Are you talking about a, I think it's called a salamander or an invisible salamander?
Like in the same vein, yeah.
Right. My brain isn't all here today, but my intuition is that there are like constructions of symmetric ciphers you can use that rule out salamanders.
Yeah, I
Go
think
ahead.
what we want here is key committing encryption. So like that the ciphertext commits to the key as well, so that you cannot decrypt it with a different key to result in something different. But I might be misremembering. I don't know, Britta. Do you remember I think it's key commitment, but.
Yeah. Once again, I'm still catching up here on what the discussion point was. So I find myself called on the I need to be here earlier. Thanks for the patience on that. If I'm catching up correctly, it sounds like we're looking at pulling a static key and encrypting the group ID and epoch to the server under that static key, or is that key coming from the key schedule? And then to the invisible salamander point about whether or not we can get the epoch ID and the group ID somehow changed up so the server is expecting something else, or are there further layers under this that I'm missing?
So yeah, this isn't attempting to hide to obfuscate the group ID or epoch. It's just that I've got a private message and I don't want the followers or I don't want the followers to be able to glean membership ID membership information. So I encrypt with the public key of the hub that's not a member of the not a member of the conversation and not in the key schedule. I'm just going to encrypt directly with HPKE to the hub, the decryption key and nonce for the individual private message only for handshake messages.
One immediate concern I would raise with that is how long-lived that public key of the server is and how many people are using a whole lot of uses of the public key. And if there's a way to keep that more ephemeral, essentially, obviously it needs to be vouched for, but more ephemeral so that we aren't exposing it so much.
Yeah, I mean, for example, if this is in the policy of the, if this key is only used for delivering handshake messages, and is expressed in the policy of the room, then it's only going to be used once per. It's only going to be used every time anybody tries to send a proposal or a commit, as opposed to being used and only in one group, as opposed to if it's shared across groups.
Okay, thanks.
That's definitely a good point about how coming stuff to the server is actually being managed. But yeah, going back, I think we're slightly confusing two things here. So on one hand, we want to chem the key nonce key pair from the secret tree of the member to the server. And there we don't have key committing encryption at all, and we probably also don't need it. And then in addition to that, we also want to encrypt the group ID and epoch. And there it might be required to have key committing encryption. And we are at liberty to define that if we want to, because that's not something that's already being used in MLS or any other protocol. But those are two separate things. I think the proposal is not to reuse the key nonce key pair from the secret tree to also encrypt the header.
I'm not making any attempt to deal with obfuscation of headers or epochs. So.
Yeah, but I mean, this is something we should look at as well, because the hub needs to have the full plain text, but nobody else does, along the route of the message. So the trade-off that we picked for private messages is the wrong one for that particular context here.
Okay, so just to play devil's advocate, what would anybody do with the group ID in the epic if all of the messages are private message?
So the epoch is probably less of a concern, but the group ID, if you have an attacker that can inspect queues of clients, then it sees the group IDs in plain text and it can just correlate which client is in what group, essentially.
So if they're inside of if they've broken the transport encryption, or they're inside.
If they're inside the follower server, for example, and so the follower server has a lot of users, then it can just agglomerate the group IDs and understand which of its own users are actually in specific groups, and then that falls into the threat model, like the typical subpoena threat model, where this is plain text data that you have to hand out and whatnot.
Right. So I think that's where Me complements this, right? But the in Richard's list of four levels, level C says that the follower can see the local membership, right? And so that's presumably, like, if you don't want, presumably that's under the control of the direct control of the user, that they can pick a provider that limits the amount of metadata that it keeps about its own users, and that they have good security policies. But I think as a separate, sort of a separate proposal, being able to hide local metadata, that's quite valuable as well.
So touching back on the question of the epoch ID, that one actually gives a lot of activity leakage, information leakage about the frequency of messaging, or particularly the frequency of updates and so forth, if it's exposed. So from an attacker's point of view, then I would know how active a given group is, and potentially also which ones are more vulnerable to targeting, because they're ending up quite likely in longer epochs. Then adding to that, if I'm interested somewhat in a group ID, I have a very clear concept of that targeting window. So these, I would say, probably we do want them both to be protected. We might consider this as all-in-one. So when I say all-in-one, I mean looking at ground up with the assumption we want group ID protected and epoch ID protected and the private message protected. But maybe instead of solving these separately, we actually look at it as a sort of a layering, where I only need, say that when I'm talking about the group ID, that needs far less protections and could be protected probably under a more static key, for instance. And then once you have that, then the server just now knows where to look up the next key to use to unwrap the next layer, so to speak. And we have these where there's more changeover, and you can use more ephemeral keys as far as who has access to what in terms of the ID, the epoch, or the private message. Over.
Yeah, good point about the epoch. I didn't think about that. And I fully agree. I mean, since we are discussing it, why not think about a holistic approach of how to protect everything? Because you see, Ron, you give us a finger here, and now we're going to take the whole hand, because why not? We can.
So yeah, I think if there's a timely proposal for the whole hand that solves the problem of the finger, and it's reasonable to implement, cool.
I mean, in a way, so what I said earlier was that the trade-off we have in private messages in MLS just happens to be the wrong one here, I think, because we already have this key that you can use to decrypt the header of a private message, so that you can actually see who the sender is and derive the particular key for that. So this is actually not accounted for, I think, in your PR. The private messages have this two-stage encryption and decryption, with the first key being like group and epoch specific, and the second key being group, epoch, and member and generation specific.
Right.
So yeah, mechanically this is probably still missing, but and then I'm wondering, the first key that we use to encrypt the header of the private message, like conceptually this is also good enough to further encrypt the group ID and epoch. I don't immediately want to suggest that we should just reuse it, but I think that this is fairly close.
Okay, so the encrypted sender data is the thing that that the hub probably also needs to be able to decrypt, right?
Yeah. Because at the end of the day, it wants to have complete plain text.
So that has the leaf index, the generation, and let's see, is the reuse guard shared across? Yeah. Okay. Okay. Fair enough. Clearly some additional stuff needed for this particular proposal. And, like we don't have enough of a quorum, I think, to go in, to say, to like take a poll or something like that. But it's good to get, as many participants that have this kind of in-depth knowledge as possible on the same page as to what we're talking about as possible.
Would it be worth for the epoch and group ID encryption to go to the MLS working group and do it there? This seems to be relatively MLS internal. And if I understood you correctly, Raphael, you're more or less proposing we just expand the sender data encryption to a whole kind of header encryption scheme. So we could make that an extension, I guess.
Be a non-safe extension. Yeah.
Yeah, it might be a non-safe extension, and it might also be tricky because you're getting a message and you somehow have to figure out like how to decrypt it. I mean, what key material to use. So this seems to be non-trivial. Like you need some sort of indicator. I think at least within the MLS working group, we also discussed, replacing the epoch and the group ID with something derived from the key schedule so that you can detect what group it belongs to, but then this raises issues where you have to process a commit and merge a commit and then again look at your received messages to figure out which is the next commit and stuff. So yeah, I think this needs some more work if we really want to obfuscate the epoch and the group ID as well.
Yeah, I mean, I was shooting from the hip a bit, just saying that we could just expand the sender data encryption. But as you say, we need some external indication what group this belongs to. Maybe this is for the MLS working group. I don't know. But I think what we should draft up is how you can the necessary secrets to an arbitrary public key, most likely the DS, but it could be arbitrary. And then how that entity can decrypt the private message. And then maybe we can determine in which working group this should go, depending on what the mechanism looks like. Yeah, Britta.
I'm wondering, do we really need it to be public in this to indicate what group this belongs to? Or is it simply that it needs to be indicated which hub it belongs to? Because if it can go to the right hub, and that then has a key that can decrypt and see the which group ID to use, and then
we can use Mimi to see which provider which hub is involved, right?
Yeah, I mean, you're right in the sense that we have an HPK ciphertext at the end of it. So we only need to identify, the holder of the private key, who's then able to decrypt that. That's correct. But then once that has happened, that's when you need to look at the group ID pretty quickly.
So, I mean, I think that in terms of a local provider, most local providers are going to want to know the room, are going to want to be able to know what the room is associated with a particular request, not just that it's a request for a specific hub provider. I'm trying to think of any provider in the world that is willing to do Mimi that would be willing to accept a message to forward it on to a hub when it didn't know what room it was.
I think the challenge here is that you have to do the decap essentially at the load balancing level, like you do with TLS typically. And that's a bit unusual, because normally you don't run application-specific code at that level in a general server infrastructure. So typically you just terminate TLS and then you have plain text and you send that to application-specific servers. Here you cannot do that because you don't know to which server to send it to, essentially, because you might want to know what the group ID is, to look up what kind of group it is, etc. So that makes it a bit unusual. I don't know if that's going to be a showstopper, but just wanted to flag that.
Okay. Well, it sounds like we, let's see if I can summarize here. So sounds like there's interest in being able to deliver this Richard's email level C of metadata privacy. There's also interest in being able to do MLS group ID and epic layer obfuscation or encryption. One of these requires, which would likely require a new unsafe MLS extension. And then the question is, is this something that providers would be willing to deploy? Would they also be hiding the room ID or not? So the big question is, if we're going to do both, do we want this to be one mechanism or two? And the other question is do we want to do now, or do we have a mandate to do this additional level of group ID and epic level protection? Does that sound about right?
Yeah, I think so. If it was up to me, I would just go ahead and look into what the holistic approach would be, and then present it to folks. Because it's, without a ton of context, it's kind of difficult to say what makes sense and what doesn't. Whereas if you have a comprehensive proposal, people can still disagree with it if they think, you know, it's too much encryption, but then they would have to make that point specifically.
Tim, did you catch that?
Yeah, I think so.
I would second that as well. That sounds good.
Okay. Cool beans. That's all I had for.
Okay, thanks, Rowan. Sounds like we could, excuse me. Sounds like we can look forward to more discussion about this on the list and perhaps at IETF 120. So if there's anything else anybody would like to discuss today, we still have an hour plus. Raphael, go ahead.
Sorry, unmuting is hard. So yeah, I just wanted to raise the awareness to what Conrad posted earlier, and feel free to jump in here, Conrad, about the overview of the requirements we have gathered so far, like the functional requirements for MIMI, and how that fares with the different privacy approaches we have, meaning MIMI and Brendan's approach. So I think that's all on the list. Just wanted to reiterate that it's indeed there and can be discussed.
Okay, sounds like there's no other business for today. So everybody gets 1 hour and 13 minutes back. Thanks, everyone, and we'll see you next time.
Thank you. Bye-bye.
Thanks, everybody. Take care.
Thank you.